Okay, ladies and gentlemen, thank you for coming. It's good to see you. I hope you had a fantastic Labor Day and a good weekend. How is Exploration VR and Exploration AR going for you? It's going okay? Good? Anyone run into any of that friction that we thought we were going to see? Okay, what do you got?
Mine was just the iPhone Windows, which I kind of predicted, but I
Yep.
had to go. I don't know. I was kind of on North Campus the whole day, and I was going into the other studio asking, like, do you have this cable? Can I connect this?
What a pain. Did you go to Groundworks?
Yeah, I went to Groundworks, and it worked in the end. But there was a thing where like the files were named wrong, so I had to change some names.
Nice. Okay. Gotcha. Okay, who else has got some friction? Yes.
Kane and Apps Anywhere was having some issues allowing me to open Unreal Engine yesterday.
Did you try and open it via the Unreal Hub or the Epic Games Hub?
No, it wasn't like locally downloaded on Grill, so I'm not sure that was an option.
Okay.
I submitted like a help ticket. I text.
Gotcha. But you got it working?
Yeah.
Okay, that's good.
I've had some similar issues with like the cloud-hosted software.
Yep.
Where like with some type of usage, it just like looks like
It says unavailable. When you go to click launch, it says unavailable.
and it doesn't give you a reason. But I just
Nice.
tried again like 10 minutes later, and then it was available.
That's how it goes. Anyone else got something fun? Yeah.
I tried to build the Unity.
Yep.
Constantly failed. Then I tried to reinstall the entire S code. It works.
Yeah, that sounds familiar. So you will kind of eventually, if you haven't already, you'll build up some basic like debugging skills. You know how like in IT, one of the most common pieces of advice and most effective pieces of advice is to try turning it off and then turning it back on, right? It's very interesting to think about why that works as often as it does. When you have a piece of software and it's being developed over a long period of time, what is a super common thing for the developers to do? Well, run it, turn it on, and then, oh, it's working, kill it, turn it back off. The moment that process fails, the developer fixes it, right? Otherwise, they can't do their testing. Which is to say that when you've got a piece of software, you can kind of think about how often did the developers check something? Where did they spend most of their time? And in most cases, yeah, it's going to be turning something off and then turning something back on again, getting back to that good state where the developers have tested a lot and it's just going to work, and they know that. Anyway, right, this is exactly what we were talking about, that friction at the bleeding edge. You want to go take EECS 494, the game dev course. Now, that's a tough course, but the difficulty does not come from weird build issues or random crashes or annoying hardware requirements. It comes from other places, like the inherent difficulty in game design. Now, in this course, a significant chunk of the difficulty of this course is just, my goodness, Unreal just isn't loading today. It loaded yesterday and the day before, but today at the same computer, same time of day, it's just not running. And getting past that, figuring out how to, asking for help appropriately, right? Getting good at, you have to try and clear the Apps Anywhere cache. You have to right-click on this. I know it doesn't look like you have to do that, but you do. And then trying it twice, and on the third time, it's guaranteed to work, right? That's the kind of debugging ability that you build up over time, okay? This is all to say, this first week is all about kind of getting past a lot of that friction, getting your accounts created, and proving to yourself that it is possible to get past some of these things. So that this week, when you run into some of the same issues, you'll have a better chance of getting past them quickly, okay? And then later on, when you get to your major projects, hopefully you won't be held up much at all, all right? Okay, anyway, very good, very good. Well, at the very least, sometimes these issues are kind of funny, okay? They're never funny in the moment, but once you get past them, they're kind of weird, okay? All right, so when you look at our schedule right here, you remember how to read this thing, right? And let me just make sure I'm streaming. Yep, I'm streaming. You remember how to read this thing. You take your eyes to the left column, you find today's date. It is highlighted in red for us. You've got the lecture agenda right here. You can click that. You'll get to all of our slides that we talk about. Later on, you'll have things that you can download, and that will help you out a lot. If you keep moving your eyes right, we see this green block right here. And it says, join P1 team size 2. That is to say, on Monday of next week, you are going to be starting your first major project in this course, okay? Your Project 1 VR project. And if you want to choose your team member, this link right here will tell you how. Basically, you're going to go in and you're going to find your team member. You're going to go to the People tab right here. You're going to go to P1 Studios, and then you will hop in to one of these along with your team member, okay? You'll hop into, I don't know, P1 Studio 5. You'll tell your friend to do the same, and once you're both in there, you're on a team, okay? If Monday comes and goes and you haven't gotten a team, later that night on Monday, I'm going to just randomly assign you to teams of 2, okay? And then later that night, you'll know who your teammates are. I encourage you to choose a team, right, if you can, all right? It's a very, very powerful thing, being able to choose who you work with. Do not sleep on that ability. Try and use it if you can, but if you don't want to, that's totally fine, okay? It usually goes okay when you get random team members. Not always, though, all right? So keep that in mind. Okay, if you keep your eyes moving to the right, you'll hit 3 yellow blocks. That means that there are 3 assignments that you should be really thinking about right now. Now, that's actually not true this semester because of the Labor Day Duderstadt Center closure. There are 2 other assignments that you could be working on today. What are those assignments? What do you got? Yes?
Exploration, VR, AR.
Yes, that's right. So our assignments from the first week, a number of you finished that already, and good for you. But those deadlines were extended until tomorrow, the 5th of September at 10:30 a.m. Okay? So you can complete those tomorrow morning if you want to. I encourage you to finish them today if you haven't. And then you can start on this week's assignments. So you've got tutorial VR and tutorial AR. These are follow-ups to exploration VR and exploration AR, in that you will be getting in to your game engines, and this week you'll actually be building out some, reasonably serious logic, okay? Now, we don't fully understand how to use these game engines yet, right? We've only got a tiny little bit of stuff going on in Unreal and a tiny bit of stuff in Unity. So, these assignments have very nice guides for you, full of videos, GIFs, images, and explanations to help kind of walk you through how to build out what you need to build, okay? For your tutorial VR assignment, you are going to be making a miniature magic show. So you're going to be programming your own little spell to kind of transform your audience members, who will jump up and clap and dance for you, into whatever you want. So in this case, I think I transformed them into squash, okay? So you'll be learning about things like line traces. You'll be learning how to spawn in blueprints and make blueprints. And that should be a pretty good time. You don't know a whole lot about that yet, so this tutorial document right here is going to walk you through all of that, okay? It will show you what to click on in the UI. It will give you an explanation for what you're doing, and hopefully it will help you get through, okay, and build some pretty cool stuff. Not super long and not super hard, but this course does require a bit of time, okay? So the way to make this course super hard is to start your assignments in, like, say, the final 2 days before the deadline. If you start this on Saturday, if you start these 2 assignments on Saturday, not going to have a good time, okay? One part of that is that there are no office hours on Saturday or Sunday. I think that's pretty typical, not to have office hours on the weekend. In the past, we had a bigger staff, so we were able to have them, but we can't this semester, sadly. So please get started as soon as you can. Get started tonight. And I can help you today, and then Patrick can help you Thursday and Friday. After that, though, things are going to get a lot harder. So try and get these done as soon as you can. Anyway, that's tutorial VR. It is not too hard, but you got to get started. Tutorial AR is, I think, a little bit of a simpler assignment. This is a little miniature kind of motor exhibition. So you're going to have vehicles of different types running around in your local space, kind of like the objects you spawned in Exploration AR. These, however, are going to move. And you're going to program a tiny bit of UI so that you can spawn more objects while you play the app. Okay? So not super hard. And again, this assignment has a big, nice guide for you. It's right here. A big, nice guide for you to follow that will kind of explain what's going on. If you look in this right gray bar over here, you'll find like tangential tips and some additional explanation for what's going on. But you can skip it if you're low on time or if you really want to. Okay? All right. Anyone have any questions on tutorial VR or tutorial AR? Okay, be careful. All right. You've got last week's assignments overlapping with this week's assignments, and so you've got to get moving to get all these done. All right? Now, before we really get into it, I want to, actually, you know what? I've got one more thing to talk to you about. So in this course, we'll be watching films, all right? I think I mentioned that the first lecture. We'll be watching 5 films on the topic of XR. As it turns out, right, art has long kind of shown visions of the future, right? Artists, they think about or discover a new technology, and then they imagine deep into the future what it could lead to, okay? The hopes, fears, and dreams of that tech. Could it lead to a utopia, a dystopia, okay? And they turn those visions, those thoughts and ideas and fears and worries into film or books or paintings or whatever, okay? So part of being a good XR developer is understanding the kind of cultural context of what people expect from XR and what they're nervous about, okay? So we'll be watching films this semester to get a good feel for that cultural context. Good news here is that generally on a film day, we won't have any lecture. So you won't have to go to any lecture. You'll get those hours back. And then the films themselves, all you have to do is be there. You just have to be there and watch, okay? If you're in that room watching that film, you're going to get those points, okay? Easy A. Now, what's going to happen is for every culture assignment, we're going to have one film viewing, okay? I'm still trying to figure out when those times will be and where we're going to be, but we'll probably be in a lecture hall, probably in Dow across the way. I'll make more announcements as that comes up. But if you're there, you'll scan a QR code, you'll get the points, okay? Now, if you can't attend, if you have some sort of athletic event or you can't be there, that's okay. You can still get the points, but you will have to watch the film yourself, and you'll have to submit a very tiny essay just to kind of verify, yeah, you're thinking about the film, you did watch the film, stuff like that, okay? All right, so what's our first film? Did anyone look? Anyone spoil it? Okay. Our first film, if you can guess it, is going to be The Matrix, okay? Who has seen this film? Okay, wow, and there's actually quite a few of you who have not. This is a very entertaining film. It is, in my opinion, very well made, especially for the time. And it has some very interesting ideas about what virtual reality could become, right? Especially in a kind of a dystopia sense, all right? Could our virtual worlds eventually become so good that it does not free us, it becomes a cage? And so I think I've seen this film every single semester since 2020 or so. And every time I watch it, I notice just a little bit more. I think it is a very clever movie. Yeah, hopefully you'll enjoy it, okay? Not super long. I think it'll be like just a 2-hour block. We'll do a little bit of discussion before the movie, a tiny bit of discussion after, and then you get all your points, okay? So I will leave you to think about what the remaining films could be, okay? because we will have 4 more after this. And yeah, hopefully you'll enjoy it. Okay, so before we get into our main topic today, I've got another company to show you. Okay, do you remember our previous XR startup, what they did? They were a company called Wide Awake AR, or actually Wide Awake VR, okay, Waver. What did they do?
They were trying to reduce global anesthetic.
Yep. Bingo. This was a medical company that was going to use VR and its uniquely immersive qualities to distract patients from the pain or the awkwardness of minor surgical procedures. So you saw footage of medical professionals doing like carpal tunnel surgeries on people's hands. And they did not use any anesthesia. They just kind of put the headset on, and it actually worked out like shockingly well. Very surprising startup. It's the kind of startup that I would not really believe this can't be possible. You're going to operate on my hand and just put a headset over me? It's ridiculous. And yet, it appears to have worked. And their mission was to decrease the cost of healthcare. You use less anesthetic. That stuff is expensive. You lower the risk of allergic reactions to anesthetic, right? And so, our conclusions seem to be that, yeah, this is a pretty impressive company. A good use for XR. Lots of good uses for XR in the medical space, it turns out. Now, I've got another company to show you. This one's called HoloRide. And while you watch this company, okay, while we explore it, I want you to think, okay? Think about this. How novel is this use of XR? How impactful is the problem that it solves? And whether this is going to be worth the financial, investment to make it happen, okay? So let's find out what HoloRide is. This is a company in Germany, Munich, I think, that has earned $12 million of investment, and you get to ask yourself whether it deserves that much, okay? What is HoloRide? Well, this is a company, a VR application, that makes your rides in the car more fun. Let's take a look at the video. Okay, so, how many of you are ready to sign up right now? This is you, okay? No? Uh-oh. Okay, what social problem is this company trying to solve? What do you got? Yes?
I don't know, but maybe they think car rides are too boring and that needs to be solved.
Oh, car rides are too boring. I'm just sitting there. I can't think of anything to do in my car that might appease my boredom. Yes? A non-existent social problem. Okay, that's a little bit harsh, but maybe I might agree with you, okay? So if you didn't quite catch it, this is a VR experience that is specifically tailored for being in the car. I mean, it's right in the name, HoloRide. Okay? And it went by kind of quickly, but one innovation that this company claims is that they will feed the acceleration, the motions of the vehicle into your headset. So one tough thing about being in a vehicle is that if you're looking down at your phone and you're not expecting a big turn or an acceleration and the car does that, you might get a little bit sick, right? You might get a bit motion sick. Your body is telling you that you're moving, but your vision is telling you you aren't. And that can sometimes cause your body to think that you've been poisoned and you start to get sick, okay? And so the idea here is that we're going to have a device attached to your car. And let me see if I can find image of what this looks like. We're going to have this device right here attached to the inside of your car, which will kind of sense the motions of the car, the accelerations of your car, and then it will send that probably over the network, local network, maybe Bluetooth, to your headset, which can then feed that into a game, and the game software can then use that data to maybe make your car in the game move or something. Okay, and that's the situation. That's the company. Okay, it looks like they are another white label company. They actually buy an HTC Vive Flow, which is the headset you're seeing here. This is a miniature headset that is kind of geared for being connected to your mobile device, and information is fed from it. If you've wondered, okay, how much might this cost? Well, how much does the HTC Vive Flow cost? The HTC Vive Flow costs $500, okay? So you know this experience may very well run you about $500. Is anyone got $500 to drop on some VR in the car? No? Daniel? Let's go. All right. But wait, there's more. Because you purchased the headset to start, but you need to purchase a subscription if you want to access any of the games or film or activities that you saw. Okay? So a subscription, what's that going to run you? Oh, all right. It is $9.99 per month. Okay? Now these are euros, so this is probably more like $13 USD per month. Or you can get full access. Well, you can do it monthly, actually, and you're going to pay about $15. Okay? So we know how the company plans to make money. All right? But whether or not consumers will go for this, it's a little bit unclear. All right? So, oh, yeah. Okay, so you want to get started. This looks really cool, right? No problem. 700 euros. Okay, hold on. 700 euros to USD. It's going to be about $775 US. Okay? What do you think? Want to go? Want to buy it now? Well, you know what? If you did, you'd probably go over here to the big Buy Now button. At which point, how many of you know how to speak German? Any of you? No? Well, I guess I can't buy it. I was going to buy it, but I can't really buy it because I don't speak German. So, yeah. How do you feel about this company? You know, we just went from medical startup being used with real doctors, lower medical costs, lower risk to, have fun in the car, right? So, we have a few criteria to evaluate these companies on. And a reminder, this is how your final project will be evaluated. I want to hear about novelty, social impact, financial sustainability, how will the company keep the lights on, and then XR emphasis. Is this something that only XR can do? Is this a problem only XR can solve? So what do you think? What do you got? Go for it. None of the above. Ooh, ouch. Okay, all right. Well, yes.
Maybe for novelty, the movement of the car to reduce the motion sickness is, I think it's still a little bit novel, and I've never heard that before.
Yeah, it's a pretty interesting idea. right? It's not a problem that a lot of technology and software is trying to solve, right? You get sick in the car, it's kind of, well, look out the window, right? But the idea that we can feed that data into your software is something that hasn't been done a whole lot. Now, maybe it hasn't been done a whole lot because it doesn't need to be done. But, yeah, it's a tiny bit novel.
Yeah, I was going to say that, but the idea of playing games, like, on VR, like, that's not really novel. The
Yeah.
motion.
Yeah. Like, this is a company that is trying to entertain you with VR. Like a lot of VR applications, right? Yeah, it's not that novel in that sense. Yeah.
Financials seem horrible. Like, think about that. They gotta pay for $250 something for the headset.
Yeah.
They gotta sell it to you the whole bundled up for $7 something.
Yep.
And then if you think about that margin, that's tiny. And then
Oh yeah.
the monthly cost is not even that much. So
Mhm.
you multiply that by the customer, it's like, whoa. And then you take out all the costs and all the ooh.
Yep. Yeah. So that's a really good point. Pointed out that the margin isn't that great, right? So if it costs the company about $500 to acquire an HTC Vive Flow, they're only getting what, a couple hundred off that initial purchase. And then they've got a subscription where they try and make that back. I will say, I'm going to show you a bunch of companies this semester that don't even have any clear way to make money. Okay, clearly they're not thinking about that. They're purely in user growth mode, which can work for a little while, but not forever. So it is good that they have some prices here, okay? But they seem a little bit unreasonable, yeah? In that it's hard to believe consumers will want to pay this much, and then when they do pay that much, it's a little bit hard to believe that would support a company. Yeah.
I was just wondering, we have like Moore's Law for laptops and stuff to know when to buy a laptop to work. But for VR, it's like, who says that this technology and this headset's going to be something I want in a year? Like, that's what I mean by the bad financials.
Yep. Yeah, exactly.
How quickly it's all changing. Well, I don't think many people would want to do this at all.
Yeah. Yeah. Now maybe they have some deal somewhere where they'll do an exchange for you, but it's unclear. Yep. So, any other final thoughts? What about XR emphasis? The problem we're solving, boredom in the car. Is this only something that XR can do?
You can always enjoy the view.
Yeah, you can enjoy the view. Look outside. You're moving, right? Now, personally, I'm not a huge fan of the freeway view in the Midwest. You go out to like Nevada, gorgeous, right? But there are so many other things that can keep you entertained while you're in the car. Not just phones, but traditional handheld gaming machines. Nintendo Switch, Nintendo DS, Sony PlayStation, PSP, music, right? Listen to music. Or imagine this. Talk with your friends and family. Okay? Socialize a bit, right? Why not? Anyway, I do like to bring this company up. I'm always nervous that I'm going to click this link in the middle of the new semester and they're going to be dead. And I'm pretty convinced that's coming soon, within the next few years. But who knows, right? With investor money backing you, you can last for a long time. But anyway, I also think that this is a great company to contrast against the Wide Awake VR, which we saw last time, which I think is a much more reasonable company and doing much more interesting things. I want to point out something to you really quickly. Let's see here. What do we got? I don't remember exactly where I found it, but you should know that this company does have a cryptocurrency. It is called Ride, all caps, and it is a cryptocurrency. And I lost the page. I think the page is like buried or something. It's a little bit hard to find. Oh my goodness, am I gonna be able to find it? I'll do a quick search. HoloRide Crypto. It's called Ride. Can we find the page? Has it been indexed? Get more details about the Ride token. Does the Ride token have a price? Ride token. Coin market cap. Ride to USD. Oh, ouch. Oh, hey. You know, if you sold in here, maybe, uh-oh. Well, bummer. Well, oh well, okay. It looks like a pump and dump may have occurred. Anyway, this does bring something up. So I do poke fun at and make fun of crypto quite often in this course. We're going to talk a little bit later about crypto when we talk about tech and hype. Crypto has some very interesting and I think very impactful use cases, but they are very niche. And making money is usually not one of those cases. However, a lot of startups stand to benefit significantly by integrating some sort of Web3 or cryptocurrency tech into their solution, even if it doesn't make a lot of sense, okay? From a lot of the startup founders that I talked to in Ann Arbor, it's very difficult to raise money right now, unless you've got some Web3 stuff going on, okay? Sometimes you can get money from investor groups just by saying, oh yeah, we're an AI startup now, right? Oh, we do AI things, yeah. And you don't do any of that. But, you know, what is AI? It could be anything, really, right? Same thing with crypto, right? Especially a couple of years ago, if your company had anything to do with crypto or Web3, right? If you could just list it as a bullet point on your pitch deck, then you were going to get that money, okay? Otherwise, you weren't. Anyway, that's how it goes sometimes. The investing world is a very strange place. We'll talk a little bit more about it a little bit later. But so that's why sometimes you find companies doing things that don't quite make sense. They want to get the interest and attention from investor groups that might fund them. Feels a little bit weird, to be honest with you. Anyway, that is HoloRide, and they got $12 million, according to Crunchbase. So, hey, good for them. You know, maybe they'll surprise us in a future semester, and but probably not. Okay, I want to show you something. Let's take a look at this real quick. So, if you're a bit of a prankster like I am, you'll discover that AR is really good for that. And here's an example of Pepsi, who has basically created an interesting exhibit, an AR exhibit, I think in New York City, or maybe this is London. This kind of looks a bit more like London. Bus stop. So this looks like it's a window. In fact, it is not a window. It's a kind of pass-through screen. And so when someone's sitting there, they can show you all sorts of fun things on the other side of it. And some of it looks incredibly impressive, right? The tiger gets the person to kind of stand up. Whoa, 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 whoa. I really like the balloon person kind of flying down. Looks fantastic. Later in the course, I'm going to show you more examples of this that are particularly terrifying, right? You can do some amazing stuff with AR if you want to get people going, okay? So this course makes a lot of use of the Viz Studio resources, right? These great computers, the VR headsets. And if you want to get access to this lab 24/7 would be a very good idea, especially for the weekend hits. You're going to want to fill out this form, okay? I think I emailed you about this on Piazza. Please fill out this form. It takes like 2 minutes, very, very quick. And then, and you should test this if possible, you should be able to swipe your M card at the entrance over there, and it should unlock any time of day, okay? Please do not prop the door open. Please just let people swipe and come in if they want to, and it should be good, okay? A quick PSA for Unreal Engine. Unreal is a strange engine, okay? It's very lovable and very powerful, but it has some quirks. One of those quirks is that if you're very used to doing Control-S or Command-S, that will only save the current thing that you are looking at, the current blueprint you're looking at, the current map file you're looking at. So you don't usually want to do that. Control-Shift-S, okay? You don't do Control-S, Control-Shift-S. That is save everything, okay? And you want to do that because we yeah, a lot of students, right? Unreal crashes a lot. You'll lose a lot more progress than you think you will if you haven't been doing that. Okay, so Control-Shift-S, please remember that. And do it like your social life depends on it. You do not want to be in here late at night recreating a bunch of stuff that you lost in a crash. Okay, that's the worst. All right, just a reminder, Exploration VR and Exploration AR are due Thursday, tomorrow, at 1:30, okay? 1:30 p.m. And so make sure you get that done. How many of you are finished with it? Awesome, very good, okay? Yep, get that done as soon as you can. Your assignments, Tutorial VR, Tutorial AR, Culture 1 have all released. We already talked about that. Not super hard assignments, but if you run into some issues and you start the assignments late, it can become very stressful, okay? So be careful. One final tip for you before we really get into it is that you should keep an eye on the course Piazza. If you get stuck in Unreal or Unity, if you encounter some friction, if Xcode will not build for you for some reason, there's a very good chance other people have seen that as well. And if one person gets past that issue in this course, we really want everyone to get past that issue. This is not a competitive course, okay? There's going to be no curve in this course, so please do not feel weird at all about helping your peers get past these issues, okay? It's a good thing to do. Just remember, don't let anyone copy your code, okay? And you'll be fine. All right. Any questions about anything? Any comments? All right. Very good. Very good. Did you? How do you feel about Exploration VR, Exploration AR? I saw some of your feedback. Did you enjoy getting the HoloLens on for the first time? Right? Pretty cool device, pretty cool experience. How many of you experienced VR for basically the first time? Well, how did it go?
Pretty cool.
Yeah. Oh, yeah. That first time you put the headset on, don't forget that.
Yes.
Yeah. It's a good time. Good time. Hopefully you didn't get too sick. Did anyone get a bit sick? The headset? Okay. So the good news is that it really does go away over time, and you do build up a tolerance for it. Pretty soon you won't feel sick at all with the headset on. It's never perfectly comfortable. I think because, you're right, they're a little bit heavy. Human beings don't really enjoy having bulky things strapped to their face. It's got to be about this light before humans can just completely ignore it. But you will get more used to it, and it becomes much more pleasant pretty quickly, okay? All right, let's go ahead and talk about game engines. Game engines are a huge topic, extremely important topic, because most of your XR development and most of your work in this course, your homework, your assignments, are going to be you looking into a big, complex game engine, okay? And what I want to help you understand in this course, what I want you to discover is that game engines, they're the same, okay? Yes, they have unique flavors. Yes, Unity is good at some things, and then Unreal Engine is better at other things. But all game engines have the same objective. They have the same functionality that they are trying to achieve. And so, all game engines will, over time, adopt very similar form. Okay? Because form follows function. As a design principle, how many of you have heard that? Form follows function. You have an object that has certain goals that it needs to achieve. And so, the object will take on the shape it needs to best solve those goals. Okay? Have you ever noticed, are any of you into like planes? Aviation? Anything? How many of you have stepped into an Airbus or a Boeing and you don't quite know which one of those two it is? Because big planes, they look pretty similar, don't they? They're made by two different companies. Why do Boeing planes look so similar to Airbus planes? Because they're trying to accomplish the same very difficult task. And so over time, they begin to resemble each other, okay? Let's say your goal in this course is not to build an XR experience. Instead, you're going to build a chair, okay? You're going to build a chair, basically from scratch. Now, you want to build a chair, okay? Now, you know you're probably going to do this by taking pieces of wood, and you're going to try and get some little pieces of metal, and you're going to try and use the metal to fasten the wood pieces together, okay? It's a pretty common approach to building a structure, whether that's a chair or a wall or something, okay? You're going to put them together, conjoin them with these little bits of metal. So you ask yourself, well, how am I going to conjoin those, okay? How am I going to drive the metal into the wood? What do you need to do that? What kind of properties do you need to keep yourself safe? Well, you might say to yourself, you need something that's strong, okay? You're going to be banging this object onto pieces of metal and pieces of wood. It better stick together, okay? You need something that's kind of lengthy, because you might try with a rock, for instance, to put this chair together until eventually you smash one of your fingers, all right? Rocks are not a great shape for this. Doesn't give you much leverage, and it doesn't protect your fingers. And ideally, you want this device to remain very simple, because no matter what, it's eventually going to break. And chances are, if you want to build a chair, right, other people want to, okay? You want to make more of these devices, more tools. And so, what kind of tool do you end up with, naturally, across cultures, across time periods? What does everyone end up building when they want to make a chair? They end up building something that looks like this, okay? Because form follows function. You want to put together a chair, you want to whack a bunch of pieces of metal and a bunch of pieces of wood, get them to stick together, you want to stay safe. A hammer has all those properties in its most simple, cost-effective form. And so, form follows function. In other words, you start with your objectives and then you work backward to build the tool. So I have a new objective for you. We're no longer building chairs. I need a tool that's going to help you build a new reality. That's a little bit harder. Okay? That's a little bit more complicated, I think. All right? You want to build a reality, not just a chair. Well, what on earth, what kind of tool could help you do that? Where would you even begin? A hammer's not going to cut it. Okay? We need something way more intricate, way more interesting. Okay? Our objectives here, when we say we want to build XR experiences, we want to build virtual realities, augmented realities, that is a complicated task. And so we're going to have a complicated tool, okay? If you look at game engines, these are the tools that help us build realities. How many of you looked at Unity in Unreal last week, or maybe early this week, and you're looking at that thing, you're like, whoa, oh my gosh, like where do I begin? What do I click on? This software is crazy. You click in the wrong place. What did I just do? What happened? How many of you were a little bit intimidated, like hopping into a game engine? It's like, whoa, right? That's how it is. And I want you to understand those tools are complicated because you're trying to play God. You're trying to build new worlds, new realities, okay? It's a complicated business you're in. So what do you expect? So this lecture is going to be all about how do we use game engines? What common features do they tend to have to help us tackle this massive task of building new realities, of playing God? Okay? We're going to talk about things like game engine basics. What do they all have? What do game engines tend to look like when they in their UI? Okay? How do game engines help us iterate and really explore the infinite creative space quickly? And I want to talk a little bit about scripting, okay? How does scripting work? How do we get logic into our experiences, all right? We're going to talk a little bit about Unity and Unreal at the same time because you are learning both at the same time. And we really want to do all of this because they're really the technical foundation of everything you're going to do in this course, okay? And, right, you needed them last week and you're definitely going to need them this week, okay? Tutorial AR and tutorial VR are harder, more involved assignments than last week's work, okay? And on your projects, you're going to spend the most of your time programming, okay? So we need to get you a feel for what these game engines are like, how to use them, and how to feel a little bit more at home in them, okay? Game engines can be really, really scary, okay? There's a lot going on in this Unreal Engine screenshot, a lot to look at, a lot to be distracted by. The good news, though, is that we don't need everything there, okay? And as you get more familiar with game engines, it'll make sense. Why is Unreal the way that it is, okay? Why is Unity the way that it is, all right? And if you really want to learn more about game engines, you take the game engine architecture course, you build your own, okay? I'll see you next semester. All right. So we need a tool for creating realities, all right? So what are realities made of? If you think about how we perceive reality, how do we do it? To a human, what is reality? Yeah.
It's kind of matrixy, but it's sensory input.
Yeah. Yeah, right? Electrical signals in your brain, as Morpheus is going to tell you at our first film, right? And those electrical signals come from what we perceive with our vision, right? What we hear with our ears, our sense of touch, our sense of taste, right? All that good stuff, all right? If you look at a typical lecture hall, you say to yourself, well, we're scientists, we're computer scientists, right? So what is reality made of? Well, atoms, right? And elements and photons and all that good stuff, and that's way too deep, okay? We don't need to go that deep. We can't even simulate that deep, efficiently, all right? But you know what? We've been dealing with fake realities for a long time, okay? If you look at this game right here, it certainly doesn't look super real, but this has been immersing people for a very long time. It has all the elements you would expect to form a semi-realistic world. There's gravity, there are things that move and touch each other and run into each other. There are sounds to denote collisions and all that good stuff, okay? We usually approximate reality, okay? We don't really care about atomic and subatomic stuff, okay? So we can begin, as we've just said, with our senses, our ability to perceive things, okay? Our sense of smell, right? You remember smell-o-vision, okay? Our sense of touch, all right? Our sense of taste, okay? I feel like an office building has a certain smell to it, right? It's not super distinct, but you can kind of get a feel that you're not at home, right? When you are walking around, you can kind of feel the texture of the carpet, the smoothness of the desks, the whiteboard, right? If you bump into someone, then you feel them as well, right? What about taste? In a lecture hall, you don't really use your sense of taste that much, do you? And for good reason. You probably shouldn't be, okay? But when it comes to visuals, right? This is a huge sense that you have, right? What makes a lecture hall feel like a lecture hall? When you see the chalkboard or a whiteboard. When you have someone up in front of the room gesturing at you, looking at you, right? When you see a big clock, you see a podium, you see a bunch of other chairs, right? Now, this piece of reality before you begins to not just resemble an empty blob of a space, but it starts to feel like a lecture hall as opposed to a kitchen or a movie theater, all right? So visuals and objects, that's a big one. Fortunately, visuals and objects are something we know how to represent digitally, okay? Hey, if I tell you this, if I tell you your first project, you have to figure out how to put smell into your project, okay? You got Unreal Engine open, you're ready to make this environment, you have to get smell in there. What are you going to do? I can think of a couple really clumsy things. Like, I don't know, maybe you can bring in like some scented candles or something to try and approximate some smell, and then you try and get it in front of the face of the player without setting the lab on fire, right? But smell is not something we really know how to deal with yet from a digital perspective, okay? So that's out. Taste. What if I tell you your first project has to have a sense of taste? What can we do? Anything? I guess we could, you could try and feed the player something, while they're playing. That gets really weird really fast. Okay? I don't know how I feel about that. Sense of touch, okay? Controllers often have the ability to do what? Vibration, okay? Vibration, rumble, okay? Give you a little bit of feedback, a little bit of texture. That's not nothing. It's certainly not perfect, okay? But it's not nothing. I'm actually going to show you some controllers and some input devices later in the semester where actually they use sound waves. They have a device in front of your head that shoots sound waves at your face to simulate little raindrops falling on you in the experience, okay? That is at Carnegie Mellon University. They have a laboratory that's all about creating really interesting, unique interfaces to try and make things more immersive. And anyway, it's very interesting stuff. But visuals, oh yeah, we can do stuff with visuals, okay? Right? We got those wonderful lenses in front of your eyes. We have a wonderful rendering pipeline to make it all come to life and make things look realistic, okay? We also have sound. Sound is a huge aspect of making you feel like you're in a place, okay? Have you ever thought about what a computer lab sounds like? Probably not. You might even say, well, a computer lab doesn't really have any sounds. But wait a second. Let's listen. It does. What do you hear?
I see.
You hear the AC. That's very overpowering. There are also some other things you probably hear. You hear fans, okay? Now, when I asked everyone to listen, everyone got really quiet. I think Nikki was actually typing and clicking over there. And I hope that would continue because clicking and typing is a piece of the ambient soundscape. It's really important. You hear that, especially if it's coming from multiple different angles, and that's a lab or a library or something of that nature. You hear people breathing. You hear people kind of shifting around in their chairs squeaking. You hear those things, and it's not just a space anymore. You know where you are. It's really important, okay? Anyway, sound is also a really convenient thing for us because we know how to represent that as well. WAV files, MP3 files, right? We can mess with and represent and play back sound very accurately, very powerfully in a digital situation, okay? It's good stuff, right? The good news here is that our most important senses, we got those covered, okay? We can manipulate images with tools like Photoshop. We can manipulate sounds with Audacity and Fruity Loops, right? Ableton and all that good stuff. I'm going to play for you a little experience, okay? I'm going to show you a lecture hall. This is a wonderful site called Sketchfab where you can get really great 3D models for free. You can use these in the project, okay? Now, tell me, this looks like a lecture hall, but why? What clues you in?
The chalkboard in front.
Yeah, big chalkboard, right? A little podium area, pieces of paper everywhere, lots of seating, a projector screen, okay? But does it feel like you're there? Not really. Let's see if we can make it just a tiny bit better. When I hear this audio, it makes me really want to walk through these doors and see everyone who's making it. And so it's a little bit hard for you maybe because you're kind of far away from the screen, but when you're close to it, you add in the visuals, you add in the audio, it starts to come to life, but it's not quite there. It's not quite good enough, right? We're missing something. What are we missing? If we want this new reality to feel real, to be immersive, we're missing something. When you looked at that lecture hall, did it feel stiff? Lifeless? What was missing? movement, okay? Life breathed into the scene. Because a lecture hall is mostly still, but not entirely, is it? You've got people there looking around, moving around, swerving in the chair, okay? You've got clocks that tick, and when it gets to a certain time, the bell goes off. You've got a chalkboard that you can draw on and leave messages on, okay? We've got computer screens that turn on and off. We've got desks that go up very slowly and down. Yes, down. We've got a staff member at the front of the room to help us with questions. We've got flickering lights, okay? There is life and there's interactivity, okay? And it needs to be there. Logic and rules are one more thing that we must add to bring the space to life, okay? Interactivity and logic really are perhaps the most important part, okay? Even very old games that aren't really able to immerse you with their visuals or audio, right? They look a little bit crufty, maybe a little bit old, okay? Clearly this is not real life. They immerse you not with their audio or their visuals, but with their interactivity, right? With how they respond to your inputs, okay? This roller coaster tycoon game certainly doesn't look real, but when you play it, when you put down your theme park attractions, when you watch people go to it and have fun and pay you, when you hear the ka-ching, when you ask for investment and then put that into new rides, it feels real, even if it doesn't look real, okay? Same thing with Job Simulator. If you look at the visuals in this game, right, it's a very goofy game. It's very cartoony, okay? It sounds like it looks. It's a very goofy, exaggerated game. It's a very funny game. But there's so much going on inside of it, right? You can interact with everything, right? And so it feels real despite not looking real, okay? Because interactivity is the very heart and soul of creating worlds that feel alive, okay? And so that is going to be a huge part of your Project 1. You aren't just creating a laboratory, you're creating the interactions that make it feel real, that make it feel alive, okay? Remember, right, one of the biggest games of the last decade looked like this. People loved it. They could not get enough. There's nothing realistic about how this looks or sounds. But interactivity, it had it in spades, okay? And so, fake realities, right? We've got visuals, we've got sounds, we've got logic and rules. And if you've got all these things, you've got a pretty impressive and immersive world, okay? Remember that. Visuals and objects, sounds, logic, and rules. We need a tool that can help us put these things together, all right? This has been the basic model for a very long time, and it's worked forever, all right? If you organize all these things, right, the images, the assets, the models, okay, where you decide to put them in relation to each other, and logic, you get the three questions people are always asking themselves. The what, the where, and the how. Okay? What is my experience, my world made of? Where are things in relation to each other? And how do they all behave and interact with each other? Okay? And game engines are built around those three rules, okay? So when you ask yourself, you know, I don't care about a hammer anymore. I don't care about building a chair. I want to build a reality. I want a reality editor. What things do you want? Okay? We want something to help us define what our reality will be made of, something to help us organize our assets, our images, our sounds, our models, our textures. We want an engine to help us move those things around, orient them, scale them, position them relative to each other to make sense of reality. And we want some tool, and this is often the hardest part, to help us define how will our objects, our actors, behave in relation to each other. Okay? How will they behave when you click on them? When you touch them? How will they move? Will they chase you around? Will they do something else? Okay? How do they work? Okay? And so, we're going to find that our game engines are built for exactly this purpose, these three main things. Okay? This is Unity. This is Unreal. Okay? This is Godot. How many of you use Godot? Anyone? Okay? This, does anyone know what this is?
Is that Snapchat's engine?
I'm pretty sure this is Lens Studio. Now, they don't call it a game engine, all right? But that's basically what it is, okay? And it kind of looks similar, doesn't it? Anyone know what this is? Now, this is a pretty rare one. I don't know if this one is still being worked on. This is Meta or Facebook's Spark AR. So this is a similar tool to Snapchat, Lens Studio, okay? Anyone know what this one is? And you'll do a double take. Wait, is that Unity? It's got a similar color palette. It has a very similar setup in structure and UI. This is not Unity. What is it? It is Apple Reality Composer Pro. So Apple's kind of a confusing company sometimes. For whatever reason, they didn't just buy Unity with their mountains of cash. They created their own version of Unity meant to help people author content for their upcoming headset, the Apple Vision Pro, okay? So you can get this Unity kind of copycat here if you want to for free online. Now, you say to yourself, what do they all have in common? If we look at the UIs here again, you'll see some very, very striking similarities, okay? A typical game engine editor has to solve those three problems that we deal with when we're dealing with realities, okay? What, right? The what, the where, and the how. What is our reality going to be made of? Where will things be in relation to each other, and how will they work, okay? Can you see any of those questions being answered in the UI? Right? What at the bottom, what is my new reality made of? All right, this is the project pane, your resources view. If you're on Unreal, this is your content drawer. For some reason, it's always at the bottom. Not exactly sure why, but almost every game engine has put this in the bottom. What kind of music files is your game made of? What kind of textures, what kind of objects and models and images is your reality made of? Okay? But then you need some way to move them around, to manipulate them, to orient them, to change their scale, okay? And some way to look it all up. In this case, almost every engine will have some sort of beautiful 3D viewport, okay, or scene view in Unity to show you how everything works, how everything lays out in relation to each other. And we also usually have a list view where things can be very neatly organized and looked up by name if necessary. Because reality gets very, very complicated and very fast. It's hard to search unless you have a special, unique way to do it, okay? And then once you click on an actor or a game object, as it's known in Unity, on the right-hand side, you'll get your inspector. You want to dive deep. You want the answers to how. How does this object work, okay? How does its logic work? How does it interact with the player? How does it interact with other objects and actors? Okay? And you can find that all on the right side here in the inspector, right? If you've got these three problems solved, then you've got a tool that can help people create realities, all right? Now, here we are in Unreal. Can you see it? Can you see where those three questions are answered, right? The what, the where, and the how. Where do we put all of our assets? What allows us to move them around and position them and orient them? And then how do we look deeper inside of them? How do they work? Right? Again, at the bottom, you've got all of your objects, your materials, all that good stuff, your sounds down here, right? Up here, you've got your kind of 3D viewport, your representation, right? The answer to the question of where are things, okay? You've got your list view and your 3D view. And then down here in this kind of bottom right corner, you have the how. You click on a chair, you can see all the components, basically the scripts, okay, that power that chair, that make that chair visible, that give that chair gravity and physics, okay, that make it what it is, right? So these are very, very similar, okay? Things are moved around a little bit, but not that much, to be honest with you. And in fact, I'll show you this in a bit. It's very easy to make Unreal look exactly the same as Unity. And vice versa, if you prefer Unreal, to move Unity's windows around to make it look exactly like Unreal. All right, here's Godot. This is an open source game engine, a fantastic game engine. I encourage you to explore it if you have time. But we got the same thing. Down in this bottom left-hand corner, we have your project structure, your file tree, all of your images, your models, all that good stuff is going in there. Okay, what is my reality made of? Right down here in the corner. Up here, you've got the list view, answering the question of where and the 3D viewport. Okay, and over here on the right, yeah, for whatever reason, how always gets answered on the right. The inspector, the details view is always on the right. Okay, not sure what causes them to synchronize like this, but they do. Let's go to MIT Scratch. Anyone remember Scratch? And when you look at this simple beginner game engine, you'll discover it has the same darn things, okay? Every game engine has to have this stuff. And so you'll look down here, your little project pane, right? For the answer to the question of what, all right? What do we have? What makes up our reality? Where, okay, you can click on things, drag them around, position them, whatever you want to do. And then the how gets a lot of space on the right-hand side. It's always on the right side. To move things around, to build logic, and to make these objects do interesting things. Okay? And you can do crazy things in MIT Scratch, all right? If you want to go crazy, you can do it. But actually, the code for this is absolutely insane. There's so much code. It's a huge pain to build a 3D game like this with the limitations that Scratch gives you. You can do it, but it's a big challenge. Anyway, the similarities between the engines don't really end there. All right, and I'm going to quickly go through this, and then we'll take a break and continue on a bit later. But it turns out, right, if you want to build an experience, right, you need a way to test it. So the play button, right? How do you launch your game? How do you launch your app? It's always usually up there toward the top, okay? Play button right there, and we've got an output, a textual output or error view right down here, the console. We need some way to get debug information or warnings or errors out of our experience, okay? And in Unity, it's up here at the top and then down here at the bottom. In Unreal, it's the same darn place, okay? Except the play button is like slightly off to the left, I guess. And it's colored, so it kind of pops out at you. That's pretty cool, okay? Output error view is down here. In Godot, it's up there as well, the play button, but it's on the top right. And the output and error view, again, is toward the bottom of the screen, okay? Every engine will have this stuff. And remind yourself of why. Every game engine is trying to help you accomplish those three main goals, right? Now, answer the question of the what, the where, and the how. And because they have the same goals, the same problems, they will become, over time, the same solutions, okay? Unreal's default interface looks like this. But guess what? You can take Unity, drag the inspector over, the list view over, and boom, you now have Unreal Engine. From a UI perspective, that's basically what you got, okay? And vice versa. Here's what Unity looks like by default, okay? On the left, you've got your list view, center viewport. On the right, you answer the question of how does everything work? With the inspector panel on the bottom, you've got the project pane, the answer to what. And Unreal, you can just drag and pull the outliner over, the list view, over to the left side. And then boom, you've got Unity, okay? Project pane on the bottom, the how answered on the right, and there you go. Same darn engine, okay? It might not feel like that right away, though. All right. Because game engines have similar functions, similar goals, they will have similar form. This is to say that when you learn one game engine, the others will come to you quickly, okay? How many of you've all learned C++ at this point, okay? How many of you have since learned a different language? C# or Lua or Java or C? How hard was it to learn that second language after learning the first?
It's easier.
Yeah, it's a lot easier. Now, not always. If you go from an imperative programming language like C++ to a declarative one like SQL, that's going to be a little bit tougher. Or a functional programming language, that's a kind of a paradigm shift. But you learn one programming language and you've learned a lot about every programming language. Okay? And that's a very powerful feeling. I remember when I was coming to Michigan a long time ago. By a long time ago, I mean like, I got here like 2011. So it wasn't that long ago. I came in knowing Java. Now, everyone was very terrified of C++, the big scary language, super powerful, super hard to use. But after learning Java, it wasn't that bad. I actually jumped straight into 280, and that went just fine. I skipped Engineering 101, skipped 183, and it wasn't too bad. After learning Java and C++, C#, it's like 2 days. It's almost nothing. Now, I remember, and here's a quick anecdote for you, and then we'll take our break. EECS 588, Computer Security course, Advanced Computer Security. At the end of many graduate school courses, you'll get to do a research project where you need to come up with an interesting experiment or an interesting little activity for you to do, and hopefully bring what you learn during that activity to the world. You write a paper, it's a good time. Well, our project at the end of the Advanced Computer Security course was to hack all of the CSE autograders. So hack the EECS 280 and 281 autograder, hack the EECS 482 autograder, okay? Hack the EECS 370 autograder. So I'm going to ask you right now, which autograder during that era was the best? Which one couldn't we hack? There was one we couldn't get. We couldn't break it open. It was too good. 388? I don't think 388 had an autograder at that time. Or if it did, we didn't try to hack it. Maybe that felt like a bridge too far, trying to hack our own professor's technology. We'll hack other professors' technology. 381? 281? It was a very good autograder, but we did get it. We used vfork in order to trick the autograder into giving us infinite time to run our code. It's really cool. Yes? 42, I recall also being a pretty good autograder, but we were able to break it. I don't remember how, though. Yeah. That was the worst autograder. And that's actually the one I want to talk about. EECS 280 was the one we couldn't break. So EECS 280 autograder, if I recall, was made by James Peretta, who's the creator of autograder.io. If anyone has used that. Have you used that? Autograder.io and EECS 280. So basically, his technology became the basis for all the other autograders that we now have. It was great. It was very containerized, so we didn't know how to break in and exfiltrate data out of the Docker container that was running the autograder. So it was tough. It was good. So EECS 370. EECS 370. I get the source code for EECS 370, which, by the way, I didn't need to get. Because the way that EECS 370 used to work is you'd be given a Perl script. Now, a Perl script it's like a little script you can run, and it's just open. It's just like a text file, so you can read it and figure out how it's working if you want to. Now, I didn't know any Perl at all. Like, I had never read a line of Perl in my life, okay, before that night. But I was handed the script, and I opened it, and I had known C++, and I knew Java and C#, though, and Python. So I was able to figure out how it works, and it took me about 2 or 3 minutes. So how it worked was, and I can tell you this now because I'm pretty sure they moved on to a different autograder and they fixed it. But how it worked was you'd run the script. It would zip up your files that represented your solution, turn it into a zip file, and it would attach that to an email. It would put your unique name in the from header in the email, and it would email it to the actual autograder running on a backend server. So that's how it sent your code to the server. And right away, this should be really spooky. Okay, if you've taken 388, alarm bells are probably going off a little bit. And one of the problems here is that a from header on just a normal email being sent, that can be spoofed. You could change that, right? You can make it anything you want. So the first thing you're going to do as an attacker is you're going to think, okay, who's my least favorite person in this class? And I'm going to change my unique name to be them while I do my evil experiments, okay? So that if I get caught, well, it's actually them getting caught, and then I run away. So anyway, by the way, you should not be doing this outside of white hat research, okay? You need to let people know if you're doing these kind of hacking experiments, and then when you're done, you need to let them know how to fix it so that they don't, fall victim to this, okay? So that people can't abuse the exploit. Anyway, what we also discovered was that there was no sort of containerization or sandboxing on the backend server. So if you want to get all the test cases, right? In most courses, the test cases are private. You cannot get them. In the game engine architecture course, you can get them, but that course is really hard. It has 1,000 billion test cases and whatever. Anyway, I wanted to exfiltrate the test cases. So what do? I write myself a program that opens up a socket connection to my own private server. So I submit my code. My code makes contact with my remote server on Amazon. And then as test cases are fed into my program, I just feed them to my server. And so now I've got a copy of all of the test cases on my server. I can read them to my heart's content. So that's not a good thing. Autograders should try and block sockets from being created, or sandbox or firewall or something to prevent that. Anyway, it was also not doing any sort of sandboxing for system calls. So have you ever heard of an RM star operation? So if you type sudo RM star into your terminal, that's basically saying, hey, I want to take root privileges and I want you to remove, aka delete, star, everything. Delete everything on the computer right now. And that will wipe the entire computer, okay? This is to say, if I've got a deadline coming up as a student and I didn't do my assignment and I want to get this entire thing delayed for maybe upwards of a week, I can destroy the autograder by putting in my program system to make a system call RM star. And then boom, it's toast, okay? Maybe I need sudo, but I don't think we did. Anyway, the takeaway here, right, not only that 588 is an amazing class and you should take it if you're a grad student here, but that Perl script, I already knew a handful of languages and I didn't need basically any help to learn a completely new one in just moments. And that is going to happen to you. Our mission in this course is not just to make you a Unity developer or an Unreal dev. We want to make you a bona fide general purpose game engine developer, which means you need to understand game engines at a slightly more general purpose level, okay? Once you know Unity and Unreal at the end of this course, you'll be able to pick up any game engine you want. And within maybe a day or so, you're moving pretty fast, okay? And by the way, I'll tell you what students usually do. The first project really dives deep into Unreal. But the second project, Unity, what you'll find is that a lot of the things you learned in Unreal, they apply directly to Unity. Sometimes the function calls have a different name. Sometimes things work a little bit differently in the UI. Things are located a bit differently. But it's there, okay? You know what's possible in a game engine. You just have to find it, okay? Anyway, let's go ahead and take a little bit of a break. I'm going to turn the music on. Let's give it 5 minutes. We'll come back a bit, and I think we're going to talk about scripting next, okay? So we'll see you then. Hey.
Contracts are waiting.
Yeah.
Help you.
If you're thinking about Face AR, you remember that one?
Yep.
And you're thinking to yourself about, how did they get in touch with that patient? And how do they get access to the patient? How do they get access to the doctor who talks in the Face AR video? The answer is extremely funny. They just cold called, 20 different people. And like one of them got back and said like, hey, like we got 30 minutes open with a patient. If you're still available today, you could get here on time. You can get time with the patient. And so they rushed over, collect everyone. They tried to finish the build they were on because it was broken, I think, at the time. They tried to fix the build, rush over there, and they got it in the patient's hand, and they brought their camera. And that's how it went. So I'll tell you this as a general thing. When you're a student, I can't remember if I said this in this class, but so long as you're a student, you have the superpower of you can never really ask for too much, and you can never actually get in trouble. Right? Because if you reach out and someone is like, okay, yeah, I want to talk to you, it's like, yeah, you're a lovable student, right? Yeah, who doesn't want to help a student? If you reach out and you ask for something dumb or like the person is offended, well, that's okay. You're just a student, right? Students make mistakes all the time. Of course you made a mistake. You're a student.
Another question. I saw that the Quest Pros had eye tracking ability. Would we be able to use this?
Possibly. So I don't know if Unreal has good APIs for using eye tracking. I think what sometimes happens is you want to use a very advanced feature of a certain headset. You usually can find like a plugin. So like, there's some obscure plugin for Quest Pro eye tracking somewhere on the Unreal Engine marketplace, or you'll find it in some GitHub repo somewhere. I've never seen it or a project that used that, but at the very end of the day, Unreal also has a C++ layer. So if you need to, you can write C++ components that should be able to interface with basically any tech you can find. So it might be a bit hairy, but it's almost certainly possible.
Okay. Yeah.
Just how low level will you have to go is the question. Hey.
So I got back from Seattle a few days ago.
Hey,
I do not
awesome.
have HoloLens.
That's okay.
Thing.
That's okay. You should send me an email and I'll add a little excuse onto your grade and you won't lose points for that part. Okay? Yep.
Get back to Timber.
What's that?
I'll have to get back to Timber.
Back to Timber. Yeah, I'll see you Tuesday.
Professor,
Yes.
I have a class at 3 p.m., so
Okay.
I have to leave right
Okay.
now.
No worries. See you.
See you.
Yep. Well, you're all getting previews. Okay. Okay, gotcha. Okay, ladies and gentlemen, let's get back to it. So, iteration, right? These worlds that we're making are big, they are complicated, and it's hard to get them just right, okay? When you look at projects like a big environment, Elden Ring, right? If any of you have played that. These gigantic environments, right? It's a very, very tough thing to get just right, especially on your first try. And a result of this, a consequence, is that iteration is extremely important. We can't afford to tell our artists, well, you move things around, you get things how you want them, and then you have to wait an hour to see if it worked out. No, that's not nearly good enough, okay? We need them to have the ability to iterate quickly. You may have seen this before. If you've taken 494, you definitely have. This is the iterative design process. Whenever anyone is doing anything creative, it's very hard to know if you're going in the right direction, okay? Will my audience enjoy this character? Will they enjoy this scene, okay? Will they get the right emotional impact out of this dramatic moment or this sound effect that I put in there? You don't know. okay? Until you've tried it out, experimented, done some playtesting, gone around this loop, okay? And as a result of this requirement, you noticed all game engines allow you to quickly launch the game, okay? They have quick play functionality. If you look in the Unreal Editor, right, you can quickly pull an extra chair out here, make it all goofy, put it on the table, okay? You can make the chair simulate physics, play it, and then you can quickly, within moments, watch how it tumbles, okay? It's really cool, actually. And so that quick play functionality is extremely important, and of course, all the engines have it. Usually it's that play button toward the top of the screen. All engines will also provide scripting functionality, okay? They will provide some way for you to write code that doesn't have to compile, or at least it doesn't have to compile very quickly. Have any of you heard of a scripting language? So, Unity, as you discovered in your previous assignment, Exploration AR, in Unity, you write C# code, right? But riddle me this, was Unity made in C#? Not really, no. Unity, as a piece of software, was written in C++. You do that for many reasons. C++ is a very fast language. It allows you to do many interesting things with memory to achieve performance, to achieve flexibility. C#, however, is a language that compiles much faster. It's much easier to write, okay? It's good for users, right? C# is the language, the scripting language, the embedded language, the guest language that runs on top of the C++ of Unity, okay? So scripting is really important. Python is a scripting language. Do you know what language we used to make The Sims 4? Was it C++? Not really, okay? It was Python. The Sims 4 is a multi-language program. The core engine that has to run very, very fast and be performant, the core algorithms for pathfinding and physics and stuff like that were written in C++. But on top of that was the scripting language, which is Python. Python 3, if I recall, okay? And this was done because you know how many lines of C++ code we had in The Sims 4? It was something like, I think like 3 or 4 million lines of code. And it took 45 minutes for a C++ compile to finish on The Sims 4. Okay? Imagine making a tiny change. You decide that, oh, it's boring when the Sims have to use the restroom, so I want them to use the restroom twice as fast. Imagine you make that change and you have to compile and sit there for 45 minutes to even know if you got the right number, if it feels right, if it's fun now. It'd be a disaster. So, Python only needs like a second or maybe less to do its compile. Okay, Python is an interpreted scripting language, so it doesn't really compile. Okay, now it doesn't run nearly as fast. It's not as performant or as flexible as a C++ compiled language, but it's fast enough for many things. Okay, so the idea here is that scripting languages that tend to sit on top of programs, they tend to offer faster iteration, okay? You can start them up faster. They don't take as long to compile. They're not as fast, but they are very nice to iterate with. I'm talking about languages like Lua, Python, C#, okay? If you take the Game Engine Architecture Upper Level CS course next semester, you'll make your own engine, and it will be a multi-language engine. So you'll have a scripting language, Lua, running on top of a C++ core engine, okay? And you do that to make the engine more usable, okay? Faster iteration, okay? Typically, these scripting languages are interpreted, or they're kind of just-in-time compiled. They are typically sandboxed. So you know if your C++ code has a seg fault, what happens to your program? What happens? Is it still running? It's dead. It is very dead, okay? The moment your C++ code has a problem, your entire program melts down and crashes, for the most part. Maybe you've got like a try-catch statement in there somewhere. But scripting languages are usually sandboxed, so that if something goes wrong in them, the entire program keeps running. That script usually concludes and terminates, but you can just reboot that script, okay? Or maybe all the other scripts running alongside it are still fine. And so the game or the app continues to chug along, okay? So when it comes to scripting, when it comes to adding logic to your project, right, this is all about answering that question, the how. How do things work? How do they behave? How do they interact with each other, right? This is typically what you have, right? You look up here, what do you see? Over here and over here. You see two different ways to represent logic, okay? This is the textual C# programming language. It is going to look similar to other languages you've already used, even if you don't know C# yet, okay? C# has a lot in common with C++. It has a ton in common with languages like Java, okay? C#, which you'll be learning a good bit of this course, is one of the most popular languages in the world. Number 5 on the TOEIC index when I took it. I probably should have added a date though. Oh, August 2022. There you go, right? This language over here, this doesn't really look like a programming language, does it? Not any language you've ever seen unless maybe you've used MIT Scratch, okay? This is what we call visual scripting. As opposed to a textual language, this is a visual language, okay? And they are both capable of expressing the same logic. They just do so in a slightly different way. They have their own positives and negatives, but they have the same expressive capability, okay? If you've ever done MIT Scratch or used another beginner level engine, then you might have seen this approach to scripting and logic, okay? Now, I'm going to ask you, I've got a challenge for you. What do you think these scripts do? You might not know the language, but you might be able to feel out what they're trying to accomplish. I feel like I shouldn't ask you, Daniel. That's cheating. So if you don't know, Daniel is on my game engine research team. What do you think? What do you think, Al? What's your best guess? Yeah, it prints a message and then it moves something. Okay? And you can see that debug.log. That sounds kind of message-like, and you've got this message beginning movement. If you look here, right, it might look similar to what's up here, right? When we begin play, we print a string. What is that string? Beginning movement. When we start the game, we print a string. What string? Beginning movement. Then, in our update function, or as Unreal knows it, our event tick event, right? We translate by some velocity, or as Unreal calls it, and I despise this name, it's pretty nasty, add actor world offset. We're moving some sort of object by a velocity. This is what it does, okay? That logic, when you attach this logic to some sort of game object or actor, as they're called in Unreal, you get this behavior. They're both moving with some sort of velocity. And you can tell that velocity is to the right, okay, by a slow amount. Now, the table is kind of interesting because it actually, it's kind of running into some stuff and moving stuff around. But the cube would do the same thing, okay? So, we've got two different ways to express some very basic logic, okay? And you're going to need this logic over here for Project 1 very soon. In fact, this week, right, you're going to get some additional experience writing logic in both of these languages, okay? So let's talk a little bit about visual scripting. This is probably going to be the newest thing for you from a programming perspective in this course. Visual scripting is all about programming with nodes. Nodes try and visualize the logic that's happening, okay? You follow the lines and you get a sense for what logic should happen. And each node is a function call, okay? Did you get a hint of that before I even said it? You've got these nodes which have a bunch of input slots on the left and usually just one or maybe none output slots on the right. Okay? The line of execution feeds in to a node, okay, via this little white line here, and it can go into a node and then out of that node if you want to have multiple nodes linked together, okay? So we've got function calls, right? And you can actually create new function calls, new nodes by right-clicking and then actually just searching. So I want a node, I want a function call that will end the game, that will quit the program. That's called quit game. Now, I really don't like this name because what if I'm not making a game? What if you're making like an automobile visualization for a commercial, right? And now you've got this quit game node as if this is a game. Well, it is a game engine and Epic Games is a game studio, so a lot of that kind of bleeds in still. Anyway, right? By the way, one of the coolest things, do you remember back in 280 or maybe EECS 183 or Engineering 101? How many of you took those early programming courses? Do you remember that classic bug where, oops, I forgot the semicolon. I forgot the semicolon on that one line. I went to compile it, and my compile message was so nasty and big that I didn't know I was missing a semicolon on line X. I wish it could have just told me. Or better yet, I wish I didn't have to write the semicolon. What if you could just right-click and then look up what function you want, and there's no typing actually for you. In fact, you can't mistype anything because the moment you click on that option, it fixes your typing, it fixes your spelling. I remember bugs where I would have a function I had to call, and it would be called like, do math. And I would write a lowercase do, D-O, and then math, capital M, and I'd try and call the function that way. But sorry, the function was actually do math with a capital D, capital M. And so I used the wrong D, I used lowercase d, and so my compiler explodes, and I lose 30 minutes to an hour before I notice that my D should be uppercase, right? That kind of bug is terrifying for new programmers. So much time gets wasted. But here, with visual scripting, it isn't possible to make that kind of issue, okay? People who are new to programming love visual scripting. Artists love it. Musicians love it. Seasoned programmers like us usually don't like it, okay? Like 20 to 25% of you in this course will probably enjoy this. The rest probably won't that much, okay? You develop a taste for it, but I'll tell you it's not my favorite way to program. Anyway, enough tangents from me, okay? Let's keep going. So we've got functions here in the form of nodes, but we also have events. We call them life cycle events because they will automatically fire at certain moments in our game, in our application. So the event begin play, this red node over here is very special. It's not a function because it doesn't really take anything and it doesn't have any feed in, okay? The event is just going to happen whenever it happens. The begin play event will occur when you run the game. It's right there in the name. The event tick event will run every single frame of the game, so 60 times per second, boom, 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 automatically. Now, the event will send the point of execution through this white wire right here, and any nodes that are connected to this white wire, this line, will run, okay? And if we want multiple nodes to run, one after the other, we can pull it out of that node and into the next one as well. I'll show you an example of that soon. So we've got parameters, these little slots that come on the left side of our nodes, And these represent the inputs, the parameters to our function calls. You want to send a string into a function? Well, guess what? You're going to send it right in via that little slot right there. You're going to make a string, you're going to feed it right in. But there are other types as well. So a vector 3 is yellow, velocity, right? A 3D point. That can be fed in. An actor data type is usually blue, and you can feed that in right there, okay? Booleans are red, which is why they have this little checkbox that you can click, okay? You can send in floats, integers, all sorts of good stuff, okay? And I'm going to show you way more. We have an entire lecture for scripting soon, all right? So look forward to that. You can have return values because, again, these nodes are just functions, okay? So we can return actors. We can return integers or booleans or whatever we want. You'll discover later that you can look up these functions with the right click and then search, but you can also make your own, all right? Which is super cool. Variables. Now these tiny little nodes, these are clearly not functions because they don't have that little slot that you can bring the white line into. And they're very small, but these little nodes, those are variables. And you can actually program what number or what value they will begin with. And you can set them, you can get them, and feed them into functions if you want to. It's a really good time, right? You got string type, you got an actor type, vector 3, which is a 3D point. If you're familiar with Unity, you're very familiar with vector 3. Boolean type, right, in red there, right? It's good stuff. So I've got a challenge for you, okay? And then actually, I think we only have like 4 minutes left. So I've got a challenge for you. Let's see if you can get it done. What does this code do? Oops. What does this code do? And by the way, you have to act it out. What does this code do? And even if you don't quite know how to program in blueprints, in this visual scripting language, you can probably get a sense for what it probably does, okay? So who would like to give it a shot? Go for it.
Go blue.
There you go. A slightly awkward go blue. The pause just a bit longer than it should be, okay? Now, the way to read this is you always go to the event, the red node, the source of our execution, our program counter, and you follow that white line wherever it takes you. So you go to the first function, print string. Well, what string do we want to print? Oh, the string has been programmed with the value go. It's been hard-coded in there. So we print go, all right? Then we go into another node, the delay node. Now, this node is actually a little bit evil. Okay, you generally shouldn't use it, but it's okay here, all right? So we got a duration, a float variable. We could plug a variable in here, but instead we just hard-coded a variable in. So we delay for 2 seconds, and then we leave out the back of it, and then we print another value. Which value? Another hard-coded string. Blue, okay? Go, blue. Okay, I've got another challenge for you. This one's a bit harder. Now, what does this do? And by the way, is stinky is true. What is this? Who wants to do it? I'm so sorry you have to do it. Go ahead.
Go Bucks.
Oh, and it hurts to hear, right? Well done, though. So, what we have here is a branch, okay? An if statement, right? Unreal just has weird ways to name things. They didn't name it an if node. They named it a branch node, okay? And that's kind of what an if statement is. One of the hardest things about learning a new game engine, you know something has to exist. It's there. It's in there somewhere. I just don't know what it's called. It has some weird name, and I'm struggling to look it up. That's really when office hours is really good, because you can just ask us, we'll just tell you. Or you can ask your AI assistant, and usually they'll be able to tell you too. hey GPT, like I need an if statement. What's the if statement called in Unreal? And they'll say it's called the branch. You use the branch node, okay? All right, so this is a variable. It could be true, it could be false. It's red, so you know that it's a Boolean variable. And I told you, is stinky is true. You're very stinky, so you're going to say go, and then you're also going to say bucks, okay? All right, but if you're not stinky, if that's false, we're actually, our execution is going to come down here instead. It's going to branch down there, okay? So there you go, right? So you can do advanced control flow in here just the way you could in any textual language, okay? Later, we're going to get to things like polymorphism. We're going to get to things like inheritance. We're going to have crazy classes and functions being overridden. We're going to create some pretty cool architectures with all of this. Like pretty much every advanced feature that you've got in your normal textual programming language, it's here as well, okay? This is the final one I think I'm going to show you, all right? What is going on here? And then we'll go home, okay? If you get it right, we get to go home. But if you get it wrong, then we have to stay here all night. Do the homework. You okay? Go for it. That's right. Good job. Very good. So, why is that the outcome? Well, we have another example of advanced control flow going on. We have ourselves a for each loop, or basically a for loop, okay? We have this for loop. The game begins, and execution flows into this for each loop node. Now, this for each loop node also takes a parameter. It takes an array. Well, what's in the array? Well, if we go backward, we work our way backward, we can see that, oh, we're making a new array. This node can do that, and it has an output. It has a return value of an array. But what is in the array? Well, our 0th element, our first element, is a string that we created with this node called goBlue. We feed it in, it becomes the first element. The second element is made by another node, the make literal string node called goU, and it becomes the second element, and the final one, and me too, gets fed in. So we have an array here that will have 3 strings in it. That gets fed into the for each loop, and then we iterate through it. So you can see there's an output execution point here called the loop body. Whatever this takes us to is going to be executed once for every item we have. So we're going to come out of this 3 times, 1 for every element in our array. And the particular element we're dealing with now also comes out as a return value. So we can print each string. Boom, we print the first string. Boom, we print the second string. Boom, we print the third string, and then we've now completed the loop. And so we come out of here, but there's nothing. And so we conclude the program. Okay? And that's how it goes. It looks weird, doesn't it? And it can be hard to follow the flow with your eyes, but you will get better at it. The rule of thumb here is you start at the red node, follow that white line, but as soon as you hit another node, you need to go backward. You need to work your way backward through the parameters to understand how they're built, okay? And that's how it goes, okay? So it's a very verbose way to program, okay? Anyone want to guess what this spaghetti ball is doing? So this is the logic in a 2D platforming game that makes the character move right when you hold the right arrow key and left when you hold the left arrow key. I think that's what the logic is, but maybe I'm misremembering it. All of that for a tiny bit of backward and forward movement. Wow. It's not hard code to write, but it does look a little bit nasty, and it's kind of verbose to do it. If you ever have to write any math in this course, and you will, that math gets really hairy and very big very quickly. Whereas in a textual language, it's just a couple characters in a line. No big deal, right? Anyway, we're going to come back to this next time. Just be lucky. Consider yourself lucky, okay? That you don't have to program like this. Because I've seen some Unreal projects that have gotten this nasty, okay? Typically in an Unreal project that is a very serious commercial industrial one, you will write some blueprint code, but as soon as it starts getting very serious and it's working okay, you convert that blueprint code to C++ code, okay? It will then run faster, it will look nicer, and then you can move on, okay? Blueprints are meant for quick scripting tasks where you've got a tiny chunk of logic and it's not going to take over your entire program, okay? Anyway, the takeaway here is it's just programming, okay? It's just programming, but it looks a little bit different, all right? When we come back on Monday, we're going to begin and launch your Project 1. And we're also going to finish talking about these game engines, and we'll dive into some of the coding and architectural decisions you'll need for P1. In fact, in this next week we're going to program one of my favorite design patterns together. I'm going to be up here with the headset on. We're going to program your affordance design pattern. Okay, this is the design pattern that makes it extremely easy to create little bits of logic that you can attach to objects in your environment and get them to do things. I'm talking light switches turning on and off. I'm talking making the copy machine activate so it can clone stuff, all right? Clicking on the exit door to quit the game, right? Little interactions like that are going to become ultra easy and very standardized when we implement that design pattern next week. So that's what we'll do, all right? Everyone, please have a great week. Please get started on your tutorial VR and AR if you haven't. And please make use of these office hours while you got them. There are no office hours over the weekend, okay? So don't wait until then. Don't wait until then, okay? All right, see you, everyone. I've got office hours for the next hour or so. I'll be here until 4:30. Let me know if I can help you. I'll be walking around. I'll throw some music on. And everyone watching from home, we'll see you later, okay? Bye-bye.